Fam, I have started this video 3 times now, and I just keep saying so dumb stuff. So I'm gonna keep this one no matter what. Please bless that we make it through, and I'm not saying any dumb things. The last thing that we did was comparing distributions. The first thing that we looked at going into comparing distributions is a back-to-back stem plot of our shoe data. So this is the number of pairs of shoes owned for all of the AP Stats students that I have this year. So I told you guys that the purpose of a back-to-back stem plot is so that you can compare two data sets, or you can compare two distributions, I should say. In this case, what we're comparing is one data set. This is all AP Stats students, and then we separated it into boys and girls so that we could informally compare the two distributions. Like, we talked about how they're both right skewed, and this one is more spread out than this one, that most of the boys own between 0 and 9, but most of the girls own between 10 and 19, things like that. So this was the first kind of sets of distributions that we compared to each other. This is the same data set. This came from the same data. Then we looked at the household size for South Africa and the United Kingdom, and this is an example of having different data sets. So we had one data set for South Africa and one data set for the UK. Obviously, we can compare distributions either way. We can compare them if it's the same data set and we're just splitting out different categories, or we can compare two different data sets but look at the same variable. So in this case, it was household size. We went through all of the socks. Made sure to add context because that's really important when you're comparing distributions. So you have to write specifically about the different categories that you're looking at. So in this case, it was South Africa and UK. And then the last thing that we ended on was you have to explicitly compare the values, meaning you have to use words that compare things like larger, less than, very, more, things like that. So what we are on to now in this video is what happens if we want to compare two histograms, because at this point we've looked at two stem plots, we've looked at two dot plots. So now let's see what happens when we look at two histograms. So you want to use percents. You want to use percents instead of counts on the vertical axis when comparing distributions with different numbers of observations. So let's get really specific about what that means. So below, we have this example of Mary. Mary was interested in comparing the reading levels for two different kinds of magazines. So the first one was a medical journal, and the second one was an airline magazine. And the way that she is going to determine the difficulty level or the reading level of these different magazines or publications is she's gonna count how long the words are. So she's gonna go through for the on the first page, count up how many letters are in each word. And I'm thinking that her reasoning is if there are a lot of big words, that means it's more difficult to read. And if there are a lot of small words, then it's easier to read. So she's comparing a medical journal and an airline magazine. And I'm sure she's investigating or thinks or assumes that the medical journal is going to be harder to read than the airline magazine. So she counted For the medical journal, she counted the first 400 words. And for the airline magazine, she counted the first 100 words. And in figure A, it shows you what she ended up getting. So to be as specific as possible, I'm going to go in and I'm going to look at one of these bars. So as best I can, I'm just going to estimate this. And what it's looking like is 92 of the words were 3 digits long. 92 words had 3 digits. 92 words had 3 digits. That's how I'm reading this first histogram. So not digits, holy mackerel, letters. Had 3 letters. In the airline magazine, this one's a little bit harder, but it's looking like 29 words had 3 letters. But there's an issue. If you look at the overall picture of the histograms, the way that these looks, to me, it looks like the words on the medical journal are much bigger than the words on the airline magazine. But you can't compare them that way because we have a different number of observations. So that's what this little box is saying down here. This figure is misleading. This figure is misleading because it compares frequencies, but the two samples were of very different sizes. One was 400, the other was 100. So of course, it looks like these words are much longer than these words because there's 300 more words on this histogram. So in order to deal with the difference in size, what we're going to do is change these counts to percents. So what they would do is they would take 92 divided by 400, and what that changes to is that 23% of words were 3 letters long. For the airline magazine, you would do 29 divided by 100, and that would give you that 29% were 3-letter words. So it turns out that the airline magazine had a larger percentage of 3-letter words than the medical journal. So just to make sure we're keeping things straight as we move forward, this left-hand one is the medical journal. I know that because of the J. And this other one is the magazine, the airline magazine. So down here, it says, by using relative frequencies, this figure provides an accurate comparison of the word lengths of the two samples. So remember, relative frequencies is just fancy for percent. So if you have different numbers of observations, you want to change your frequency to relative frequency and compare the percentage instead of the count. Now, you've seen this before. We looked at this when we were doing bar charts, and they were giving us the percent of 7th graders that participated in the service activity, and the percent of 8th graders that participated, and the percent of 9th graders that participated. This is the same idea. What percent of the words in the medical journal were 1 digit long? I think that that is 1%. What percent of the medical journal was words that are 2 digits long? I'm thinking this one is approximately 13%. All we can do here, though, is the best that we can. We're just doing estimates, so we might be a little bit off. This could be 14. This could be 22. We're just making the best estimate that we can. Over here, this is looking like, I don't know, 7. I'm thinking 7% of the airline magazine had 2-letter words. I think this might be 16% of the airline magazine had 3-letter words. Or I shouldn't say it like that. 16% of the words in the medical journal sample were, or not teacher, can you get a grip? So let me say that again. 16% of the words in the airline magazine had a length of 3 letters. And I should be even more specific and say 16% of the sample from the from the airline journal were 3 letters long. Guys, I am really doing the best that I can. I am so sorry that I am struggling to keep these straight. So let's recap, because I feel like I've just been babbling on forever. The heart of the matter is, if we're going to compare histograms, they either have to have the same number of observations, or you have to change the counts that you have in one distribution, 2%, and the counts that you have in the other distribution, 2%. Now, I've never seen a case where you have to do this. I've never seen a case where you have had to do this to make histograms, but you want to be aware that you cannot compare these two things because the observations are different, but you can compare these two things because you've changed it to a percent. So now that we've done that, it wants us to compare the distributions. Now that we have done that, it wants us to compare the distributions. So we're going to focus on figure B only. What do you think the shape of the distributions is? So you decide without me. What do you think this shape is? What do you think this shape is? Give you about 10 seconds. 5. Okay, so I think they're both skewed right, and they both have only one peak. So the distribution of word length for the medical journal and the airline magazine are both skewed right, or right skewed, whatever you prefer, and unimodal. Notice that I'm being as specific as possible. So I'm saying the distribution of word length for the medical journal and the airline magazine. I'm using the context from the problem. Okay, now we got to find the median, but here's the deal. We know that the median is the middle of the data set. So we know median is the middle of the data set. Well, now your data set ranges from 0% to 100%. So where would the median be? Well, the median is now between 50% and 51%. If you have to have 50% to the left and 50% to the right, then essentially what you're doing is checking to see what bin is 50% in. That bin, or that number of letters, will be your median. So for the medical journal, what I have is that this is 1%, this is 13%, so that puts me at 14%. If I add this 23, that puts me at 14 plus 23 is 37%. So up to this point is 37% of the data. Okay, in my next one, that guy's looking like 7, and this guy is looking like 5-ish. I'm just estimating. Okay, so this takes me to 44%. This takes me to 49%, So that means, I'm not feeling great about these percentages. 1, 13, 23, 7, but I guess they are pretty accurate. So up until this point, I have that that's approximately 49% of the data. If you add up all these percentages, you get 49%, which means that your median has to be in this next bin. Your median is in this bin because this bin takes you up to, we'll say that's 8. This bin would be 57% of the data. Well, let me say that differently. This is 57% of the data. So that means your median has to be in this bin, because this is 49% of the data. Let me use something other than my fingers. So up until this point, if you add up all these percents, that's 49% of the data. So if you add in this bin, that gives you about 57% of the data, which means that the median is probably in here. So that is a median of 6. Now we have to do the same thing for the airline magazine, and I want you to try this without me. So pause the video and see if you can figure out where 50% is, what bin 50% is in. Really pause. Okay, so if I add these, I get 7 plus 16 plus 29. Oh, that puts me at 52. So this is 52% of the data. So that means for this distribution, the median is likely in that bin. So the biggest takeaway is if you have to find the median for a relative frequency or a percent, you're looking for 50%. Okay, so that means that the typical word length for the medical journal is larger than the typical word length for the airline magazine. The median for the medical journal is 6, and you can say letters if you want. And the median for the airline magazine is 4 letters. So typically the words in the medical journal are longer. Okay, now they want us to talk about variation. The distributions have about the same variation. The word length for the medical journal varies from, okay, so I'm going to come up here, 1 to 13. 1 to 13. Not 14, because 14 belongs in the next bin, in the bin over. And the word length for the airline magazine varies from 2 to 13. So those are very similar. That means that the range for the medical journal is 12, and the range for the airline magazine is 11. Those are very close. The range is 12 and 11. Now down here I have a note. We should use IQR to compare the spread because both of the distributions are skewed. But it is challenging and time consuming because we would have to estimate the percent that each bar represents. And this would not be easy to calculate because I think some of these are like decimals. Like I think that this is close to, if this is 7, then this one would have to be 6.9%. So I think it would be hard to go through and actually find your IQR because you would have to estimate so many percents. And by the time you estimate, it might not be that accurate. So overall, I think we're better just to use range. If this were a test question, you should just move forward with range and not worry about IQR. If the percents were easier to estimate, I would tell you to do IQR, but they're not. If you really go through and look at those bars, the percents do not go to whole numbers. They go to weird decimal numbers. So if it's easy to calculate IQR, then you spend the time and you do it. But if it's like this graph, you use the range and hope for the best. Okay. We're almost done. Hang in there. Okay, then what's the last thing that we need to talk about? We did shape, center, spread. Ding, 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 it is outliers. So I don't think either has outliers. So I'm going to say neither distribution of word length appears to have outliers. Neither distribution of word length appears to have outliers. Whew, 1 page of notes took 4 days. Sorry about that. Okay, it's been kind of a long road, so I'm going to quickly recap. If you're going to compare histograms, you need to have the same number of observations. If you do not, take each distribution and find the percents. So you take this, all of these counts, and divide them by 400. You take all of these counts, divide them by 100. Then you can compare using the percents or the relative frequencies on the y-axis. We have to do that because the graph can be misleading if your number of observations is not the same. Once they're the same, you can go through and do this comparing distributions with shape, center, spread, outliers. Now that we've gone through that, I want to visit one of the problems in the Can You Do. So if you have that by you, grab your Can You Do, because there's one that I would like to talk about with you. Teacher, where's yours at? Okay, so you have a problem in the Can You Do. I'm just going to try the best I can to cover up the solution. That says, explain why you can't compare these two distributions for the Yankee salary and the Phillies salary. So these are both histograms. So the first thing I thought was, well, there's obviously got to be different numbers of observations. So I go through and count up the number of players, and it turns out that there is 26 players on the Yankees and only 25 players on the Phillies. So I said, you can't effectively compare these because they have a different number of players. And look at the x-axis. Look at the bins. If your bins aren't the same size, then you can't compare them. So then they give you a graph that is accurate. So this is an accurate plot for us to, I shouldn't say accurate. This is two histograms where they have adjusted the x-axis. But what is interesting is they didn't change it to percent. They kept it at 26 and 25. So it's seeming to me like if your observations are so close in number that the difference is negligible, and what that means is it doesn't really make a difference, it's not going to cause a huge change, then you don't need to change it. So 25, 26 players, what your book is telling me is that's not big enough to create a huge issue. But 100 words compared to 400 words is a big issue. So I think the takeaway is, if you're going to compare histograms, you got to make sure that your bin sizes are the same, and you want your number of observations to be comparable. So if one has 30 observations and the other one has 32, you're probably okay. But if one has 30 and the other has 25, I'd start considering using percents. Definitely 100 to 400, too much of a difference. You absolutely have to use percents. If you're ever in doubt and you can ask me, or else just use your best judgment. So you have to have close to the same number of observations, and you have to have the same bin sizes in order to compare histograms. So now that we have this done, our entire comparing distributions is done. Sorry, I didn't mean to freeze. I meant to make myself little. What you should go through now and do is your can you do number 5. You should do your can you do number 5. And you should watch the solutions, family. You should watch the solutions. So, my B days, my 2B, my 3B, now you go and do your can you do. And you persevere through the video solutions. Okay, love you.